chapter 2. Real numbers. Now this set, the real numbers, contain all number sets that you have already learned. The set of natural numbers, the set of whole numbers, the set of rationals, set of integers, and one more set of numbers I think you haven't learned is the set of irrational numbers. All these together form set of real numbers. So first we will recall few things. Set of natural numbers, this we already discussed in the last chapter or the first chapter of the Maths Part 1 section, set theory. There in the intro lecture itself I had talked about all these sets. This is set of whole numbers. Next, set of integers. Then comes Q. That is set of rational numbers. It is of the form P by Q, such that P and Q are integers and Q is not equal to 0. Next is the chapter on which we are going to learn is set of real numbers. And when we learn set theory, we learn definition of subset. So using that definition, if I want to find the relation between these sets, then how it will be? N is subset of W. Yes, because every element in N is contained in W. So N is subset of W and W is subset of I because every element in W is in I. So W is subset of I. I is subset of Q. Why is that so? Every integer is a rational number as well because every integer we can represent it as, suppose 1. We can represent it as 1 by 1. If I am talking about 2, I can represent it as 2 by 1. So this is of this form where Q is 1 and it is not 0. So every integer is rational. So every number here is contained here. So I is subset of Q. Similarly, Q is a subset of R. So if we notice, N is subset of W. W is subset of I means N is subset of I. Right? This is a bigger set. This is much more bigger. So again N is contained here since W is contained here. Like that we can go. So R is the most biggest set which contains all these set of numbers. That is, it contains rationals. But it contains much more. That is, it contains irrational numbers as well. So in this chapter we will be talking about what are irrational numbers. Okay. So any number which is not rational is irrational. And we will come across such numbers as we proceed further in this chapter. Okay. So this we have to recall few things which we already know. Then next thing which we need to recall is the order relation of rational numbers. So suppose we have, I will take an example first and then we will write down. Suppose we have two numbers, 1 by 2 and then 2 by 3. These are two rational numbers. No, not natural actually. I wrote it wrong over here. I want order relation of rationals, not naturals. In naturals it is very clear actually. Yeah, when we have two rational numbers now. Now, what is order relation means? Which is greater than the other, that we need to find. So for comparing any two rational numbers, which is the first thing that we do for adding two rational numbers or for subtracting two rational numbers or for comparison, first thing which we need is we have to equalize the denominator. Also we cross multiply and we get, how do we equalize the denominator? I multiply and divide by the same number. So here I will multiply by 2. So I end up that this 1 by 2 is equal to this, because if I multiply the same number, the rational number remains same. The ratio remains same actually. 3 by 6, and here I have 4 by 6. So now which is bigger? 4 by 6 is bigger. So we have the relation that 1 by 2 is less than 2 by 3. So now once we have equalized the denominator, we need to compare only the numerators, and we have to just order it just like we do for any integer or any natural number. So 3 is less than 4, that's why 3 by 6 is less than 4 by 6. Because this is a greater number and this is a smaller number. When we divide by same number, this will remain greater and this will remain smaller. So we got this relation after equalizing the denominator. So in short, what we are doing is we are just comparing these two numbers. The denominator is anyways equal, so nothing to do with it. So how do we find the relation? That means I need to compare 1 into 3 with 2 into 2. Which is greater will form that, which product is greater, that will form the greater rational number. So I have to compare just these two numbers to know which rational number is larger. So here I have 1 into 3 is less than 2 into 2. So 1 by 2 is less than 2 by 3. Similarly, now let's discuss the general case. So when I have two rational numbers, P by Q and S by T, these are two rational numbers, then rational numbers means what is the condition? Q greater than 0 and T greater than 0. Okay, then P by if P into T is less than Q into S, then P by Q is less than S by T. Similarly, if 2 is greater than Q into S, then P by Q is greater than S by T. And if we have equality, that is if P into 2 is equal to Q into S, that will give me that the both rational numbers are equal. Okay, so to order a rational number, we need to equalize the denominator. But however, to compare two rational numbers, we can just use the cross multiplication, and don't need to write all those stuff. We just need to compare the numerators. That's why we just compare P into T and S into Q and arrive at the answer. Okay, so P into T is less than Q into S, then P by Q is less than S by T. P into T is greater than Q into S, then P by Q is greater than S by T. And if P into T is equal to Q into S, then both the rational numbers are equal. So this is how we order this. You have already learned. This is just a revision or recall. We are recalling all those things. Okay. Now next thing which we will learn in this is we will learn some properties of rational numbers. Okay. So the properties of rational numbers. So there are 4 properties which we are going to talk now. First one is the commutative property. So first we will discuss what is commutative property under the operation of addition. Okay. First we'll talk about when we add rational numbers, what does commutative property mean? When we add, commutative property means if I have two rational numbers A and B, then commutative means A plus B is same as B plus A. Associative property means if I'm adding 3 rational numbers, so the order of addition is not important. If I put A plus B plus C, we have already learned that when we simplify, first we first we simplify the brackets and then the outside part. So here I am adding a plus b first and then I will add c. Now this is same as if I had b plus c first and then add a. So this brackets I can put here also, this won't matter, the value should be same. That is what is meant by associative property. Then comes identity. There is an identity in set of rationals. When we come to addition, that means when I add that identity, I should end up with the same answer, same number or a. When I add a with that particular identity, I should get. So it is a. When I add 0, so when I add 0 to a, I end up at a itself. And inverse, that means a plus that number should give me the identity. That is what is meant by inverse. So these are 4 properties. So inverse means when I add a number with its inverse, I should get identity. So with what I should add? Minus a. A minus a will be 0. Plus minus means I have to subtract, and a minus a will give us 0. So identity means a number. Now 0 is a rational number. Okay, 0 upon 1. So I need to find a rational. Now I have got a rational number which if I add to any other rational number, I will get the rational number itself. Means a plus 0 is a for any a which is a rational number. Inverse means when I add a to its additive inverse, I get again identity back, that is 0. So I have to add with minus a. So in set of rational numbers, all these properties are satisfied. Since 0 is a rational number, we will find identity for any other number. This inverse, every number's negative part is a part of rational number, so again we will get inverse also. So these are the 4 properties. So if I talk about the operation of multiplication, it will be slight change. In place of plus sign, I can put multiplications. A into b is, so when I am talking under multiplication, commutative property means a into b is same as b into a. A into b into c is same as a into b into c. And what will be the identity if I am talking about multiplication? I need to multiply to some number and I should get a itself as the answer. Then that should be 1. A into 1 time is a. So 1 is the identity under multiplication. And inverse means I should get a into some number should be, the answer should be 1. So which will be that number? I need to divide it by a. That means dividing a by a is same as multiplying a with 1 by a. So when I multiply a with 1 by a or its multiplicative inverse, I end up at the identity, that is 1. So these 4 properties are satisfied in case of multiplication as well. Okay. Now let's discuss the next topic. Okay, the next thing that we are going to recall is in standard 7th you have already learned that there are 2 types of rational numbers or 2 types of decimal forms. Decimal form means if I have, this is a rational number, then what is its decimal form? I have to divide 2 with 1, then I will end up at the same as 0.5. How do I do that division? To divide 1 by 2. So first is 2 zeros are 0 and I get remainder 1 back. Now here I introduce, now 1 is same as 1.0. So now I will use this 0 over here. So before using, I will introduce a point over here and I will use a 0 here. Now I can write 2 5s are 10 and remainder is 0. So I got the decimal form. This is how you find the decimal form. This you have already learned in standard 7th. Okay. So 1 by 2 is equal to 0.5. Now this is a terminating type. Similarly, 2 by 5. Decimal form is 0.4. Again, this is a terminating type. Now let's discuss the recurring type, or recurring is non-terminating type. Non-terminating and recurring. Consider 17 by 36. Now this will give me 0.47222, and this will go on, means this 2 will repeat again and again. That's why it is recurring type, and it is non-terminating. Non-terminating means it is not stopping anywhere. Now here terminating means at 5 it stopped. The numbers are not continuing. Here this 2 is continuing. That means it is not terminating anywhere. It is not stopping. It doesn't have any dead end. And recurring means particular number or particular numbers are repeating. Here only 2 is repeating. So this we used to write using this. I put a point above it. Yeah, I think you remember the notation. Okay. Okay, I will keep this. Another example. Consider now this will give, if you divide it, this will give me 1.2692307, and again 6922307. This will repeat. So this part is repeating. So these two types, I hope you remember, where this is a terminating type and it is stopping somewhere. Here it is not stopping, and particular numbers or particular set of numbers are repeating. Here 6 won't repeat. Here 6 will repeat, 2 won't repeat. Okay. A group of numbers or single number is repeating again and again. That is recurring. So non-terminating recurring type of rational numbers, and this is terminating type of rational numbers. Okay. Now here we had learned how to express a rational number in its decimal form. We used to divide 1 by 2 and introducing zeros until we end up at a remainder 0. Okay. So now we will learn how to do vice versa. We will be given decimal forms and I need to find its rational form or its ratio form, P by Q form of it. Okay. Okay, so now we will learn how to express the recurring decimal in P by Q form. So consider an example, 0.7777 and this. Now this particular recurring decimal form, I have to express it as P by Q form, in P by Q form. Okay, so let's suppose X is 0.77. Okay, now this is same as. Alright, now I will introduce, multiply this number with 10 suppose, then what I will get should be 7.777. So this I can express it as 7 point dot. Okay, now 10x minus x. Now my aim is to remove this decimal part. So for that I am doing this. Now if I subtract it like this, now I will get rid of the decimal part. From 7.7 I will get rid of this 0.77 part and I subtract. So I will get just 7 over here, and 10x minus x is 9x. Okay, because 10 minus 1 is 9 and then x common. Now I have x is same as 7 upon 9. When this comes this side I have to divide. So this is how we convert the recurring decimal form into P by Q form. So we just need to get rid of the decimal part by multiplying by 10, 100 or whatever is the requirement. Now let's consider another example. take a bigger number. 7.529. 529. 529. Now this three numbers 5 to 9 is repeating again and again, so I can write it as x equal to 7.529. 529 repeating, and this is same as 7.529 bar. Okay, now I need to get rid of this 3 decimal places. So what I will do, I will multiply by 1000 to x. Now 1000 times x will be 3 decimal places forward. When you multiply by 10,000 or any such numbers, you have to count the number of zeros, and that many times you have to shift the decimal point of the number towards right. And when we divide by 10 or 1000, we have to go towards the left. So when I am going towards the right, I will end up here with this number, right? Okay, so now for getting rid of this part, I have to subtract from this the x. So 1000x minus x so give me 7522. Okay, this part will get subtracted and it will become 0, and 9 minus 7 will be 2. Okay, so what is 1000 minus 1? It is 999. It is 999x. The same as this. So what is x? X is 7522 upon 999.